Welcome to Tutor Sam Academy, where complex is made simple. Today we're discussing set. Before that, subscribe to our channel.
Elementary set theory. So before I go into what set theory is all about, what is set? By definition, what is set? Set is the collection of well-defined objects, figures, people, or things. Set can be defined as the collection of related objects, people, figures, and things. And sets are denoted with capital letters. Sets are represented with capital letters. You can represent a set with either A, B, C, or D. And we have what we call the elements of a set. The elements of a set are referred to as the member of a set. And every member of a set are represented in small letter. That is, if A is a set, I can represent the element of my set to either be A, B, C, D in small letter. So that is what set and element of a set is all about. So that's the difference between a set and element of a set. And membership in a set is defined in two ways. Members of a set can be defined in two ways. We have what we call the enumeration method. One of way to describe a membership is enumeration method. And we have number two, we have the descriptive method. So these two methods will help us to describe the membership of every set. When we talk about enumeration method is simply referred to as a roster method or a listing method. Listing or roster method. That is what enumeration, when you enumerate something, when you list the member of a set, or it can also be referred to as roster method. A typical example is when I have a set A to be 1, 2, 3, 4, 5. This is what we call enumeration. I list the member of this set A. While descriptive method is a type of method that the member of that set is being described. That is, when I have something like this, this is enumeration, this is descriptive. When I say set A, X belongs to A, such that X is an even number. This is a descriptive method of describing a set. This is enumeration. Descriptive means that I did not list the member of that set, but I describe it. That is descriptive method. All right, in describing a set, having looked at the method of describing the membership of a set, in describing a set, we have what we call a finite or infinite set. So a finite set is a type of set whose membership are countable. That is, there are some sets that their members are countable. For instance, when I said A is 1, 2, 5, 3, 4, 5, this is set A. The members are from 1 to 5. So this type of set is countable. This is an example of finite set. While infinite set is a type of set whose member is uncountable. That is, A can be 1, 2, 3. This is to infinity. This is to infinity. The members are not countable. Or we can say A. Let me use descriptive to represent an infinite set. I can say A is an integer. See, this is X belongs to A such that, this line here means such that X is an integer. This descriptive or this type of set is an infinite set because integer can be to infinity. So this type of set is uncountable, though this is an example of infinite set. Secondly, we have what we call equality and equivalent set. Equivalent set. equality and equivalent set. Now, equality set or equivalent set, equality set is a type of set, or let me say a set is said to be equal if every member of A is also a member of B. That is, the number of elements in A is also in B. For example, two sets are said to be equal if I have set A to be 1, 2, 3. All right, two sets are said to be equal if every member of A is also a member of B. When I have this kind of set, I call them equal sets. You can see that this is set A. This is 1 is here, set B, 1 is there. 2 is here, 2 is here, 3 is here, 3 is here, 1 is here, 1 is also here. So this is an example of an equal set. It doesn't matter the number of elements here or the number of elements here, but everything you have in A is also in B. That is an equal set. Now, when we talk about equivalent set, two sets are said to be equivalent when the number of elements in A is also the same thing as the number of elements in B. For example, this A, B, and C. Set B is 1, 2, and 3. Here, this is an equal set. Every member here is also a member here. This is an equivalent set because the number of elements here is the same thing as the number of elements in B. So this is example of an equivalent set. Now, two more examples. Now, let's take this example. The question said, given that D or X belongs to D, this is the set, such that X is an integer, 11 less or equal to X less or equal to 18. List all the member of D. Now, follow me carefully. Solution. The question said we should list the member of the X belong to D. X is an integer. This is a descriptive method. X belongs to D. X is an integer. 11 less or equal to X less or equal to 18. For me to list the member of this set, I will work with this inequality. This is 11 less or equal to X less or equal to 18. This is how you list the member of this set. Take this first part. They said 11 is less or equal to X. That is, 11 is less or equal to X. That means if I'm to list the member of X, if I'm to start with this statement with X, I will say X is greater or equal to 11. That is, so to know X now, X will be what? Greater or equal to what? 11. That is, they say X belongs to D. X is an integer. X is greater or equal to 11. So we know three things about X. First, you know that X belongs to D. X is an integer. And also, X is greater or equal to 11. That is, X starts from 11 upward. So this is the first part of the inequality. The second part of the inequality says that X is also greater, less or equal to 18. So if X is greater than 11 and less than 18, that means X starts from where? 11, because equal to is here. 12, 13, 14, 15, 16, 17, and 18. Do we understand that? So X is greater or equal to 11. X, this equal to means that 11 is inclusive. So from 11, and X is also less or equal to 18. That is, it is less than 18 and equal to 18. So this is the member of set D. So I can say, since X belongs to D and X is this, that means D will also be 11, 12, 13, 14, 15, 16, 17, and 18. So this is the member of set D. If you have watched me to this point, do it to like, subscribe, and share. All right, example 2. The question says, let n be the set of natural numbers. That is, n is a natural number. List explicitly member of the following set. This is the set. That is, if n is natural number, we should list the member of this set. X belongs to G such that X equal to 2n. N is a member of this natural number. 1 less or equal to n, less or equal to 5. So for us to list the member of this set, this is a descriptive method of describing a set. We list this first. We have, all right, solution. We have, for us to list the member of this set, I will start with this inequality here. The inequality is 1 less or equal to n less or equal to 5. So for me to know what n is, I will rearrange this. If 1 is less or equal to n, that means n will be greater or equal to 1, and n is less or equal to 5. So 1 is less or equal to n is greater or equal to 1. That is, n starts from 1, and that same n is less or equal to 5. N starts from 1 and end at where? 5. So n will be 1, 2, 3, 4, and 5. You have to understand that if I did not have this equal here, I would say n is less than 5. But because of this equal to, that means 5 is inclusive. If I have n is greater or equal to 1 here, if this equal is not here, n will be greater than 1. That means I will start from 2. But because equal is there, 1 is inclusive. So from this, I can now substitute into my x. So x is equal to 2n. So it is x that belongs to G. The next step will now be x is equal to what? 2n. Each of these n will be substituted here. N times 1 will give us 2. This is 2. This one will be 2 times 2 will give 4. The next one is 3. 2 times 3 will give what? 6. Then 2 times 4 will give 8. 2 times 5 will give 10. So these are x because it is x that belongs to G. So x is 2, 4, 6, 8, and 10. So G will also be 2, 4, 6, 8, and 10. Let me come again. The question said that let n be the set of natural number. List the member of this set. So this is the set. X belongs to G. X is equal to 2n. And this is our description of n. They describe n as 1 less or equal to n less or equal to 5. So for me to know what n is, I will start the inequality with n. That is why when they said 1 is less or equal to n, if I'm starting with n, it will be n is greater or equal to 1. So n is greater or equal to 1, that is n starts from 1, and n is less or equal to 5. N is equal to 5 and it is less than 5. So this is my n. For me to get x is equal to 2n. Anywhere I see n, I put each of these. So this is 2, this is n, 1, this next one is 2, the third one is 3, 4, and 5 respectively. So this is 2, 4, 6, 8, and 10. So these are elements of set G. Thank you very much for watching. Do it to like, subscribe, and share.